This is the intro video to the energy of a pendulum gizmo. Okay, so you are looking for the gizmo titled Energy of a Pendulum. And this will encompass LTs 1 through 3, and heck, actually 4 a little bit as well. Alright, so this covers the majority of the energy unit. In terms of due date, depends when you're watching this video. Alright, so make sure you throw your name on it. There's always a couple of those anonymous gizmos that get turned in, so make sure you put your name on there. Alright, prior knowledge. Toy car is about to roll down a track as shown below. At what point do you think the car will reach its greatest speed? You just mark on this track. I think everybody's played with a toy car before. You've seen something roll down a hill. Where do you think it will be going the fastest? And you mark that point on the image. Alright, so I have a hunch it might be about at the bottom. This gizmo looks a little more difficult than some, but it is not. A pendulum is a fancy name for like a little bob thing. They'll call it a bob or a ball on the end of a string. Alright, it swings back and forth. So it's almost like the guts of a grandfather clock with the pendulum that goes back and forth, if you know what one of those are. So a pendulum consists of a weight that is suspended from a pivot. That's the pivot. At what point will it be moving the fastest? Okay, so if somebody starts and they hold on to the bob here and then they just let it go, at what point in the swing do you think it will be moving the fastest? And you are marking that on the image with another X. Okay, so take a guess. Where do you think it's going to go the fastest? I have a hunch here. What do these two situations have in common? Okay, there could be a variety of answers here. It could be that you think they're going the fastest at the bottom. It could be that the main force that's in play here is just the downward force pulling down. That's the one I'm going to go with, is that the primary force causing the motion is gravity. Okay, on the warm-up, as always, I can't show you both, so hopefully you have your Chromebook fired up. You are on energy of a pendulum gizmo. If you need to pause me to get there, then pause me to get there. This stuff isn't going to make sense. It says objects have several types of energy. Potential energy depends on position or shape. Kinetic energy is the energy of movement. This gizmo allows you to explore how the amounts of these types of energy change for a pendulum in motion. So we have our x-axis, we have our y-axis, we have our pivot, we have the little bob swooping back and forth. You need to be on the description pane, which is one of the first ones. It is the first one, to the left. And it says change the initial angle, which is theta, to 40 degrees. So drag the little purple slider to 40, and what you should see is the pendulum cocked back farther to the right. I'm going to click play. Look for how does the velocity, which we know is speed and direction, change as it swings from right to left. So all we are going to look at is this swoop here. Okay, that swoop there. And so you click play, and you watch it go back and forth. And even if you look left or right, it looks to me like our guess is fairly accurate from up here, from the top, that as it goes from right to left, it increases its speed towards the bottom, and you think about its direction also changes. It's kind of going here, then it's going to go straight this way, then it's going to take an angle again. Alright, so direction also varies, we're going to say. Okay, that's not a constant straight line motion by any means. On the image, mark the point where the pendulum swings fastest with an X. So I would say that we know now it's right there. And the other one, circle the 2 points where the velocity is 0. So right before we click play, we know that it's 0 here. But if you're this pendulum, it's going to swing back to about this point here, then it's also 0 there, okay, before it comes back down. That looks like some weird, creepy face staring out at us. Okay, to the back. And actually, I forgot to double side this round, so maybe it's not the back for you. Potential and kinetic energy. It says we're going to click reset. So that's a little curly Q arrow. So click reset. Check that the mass, so the M is 0.5 kilograms. The length is 2. That is the length of the string. And theta is 40. So it should be set to that right now. We're on Earth, so gravity is 9.8. Intro. An object that has a certain height above the ground has the potential to do work and therefore has potential energy. This type of potential energy is called gravitational potential energy. GPE is perfect. A lot of times we just call it potential energy. Unit of energy is the joule. So number 1, select the bar chart tab. It's the third tab. And show numerical values should already be checked. But double check on yours to be sure that that box is marked. And it says click play. What do you notice about the gravitational potential energy, the PE, the KE, the moving energy? TE is not thermal, it's total energy. Okay, so what do you notice about those? So as you click play, the more teal bar goes up and down, kind of the ugly lime green bar, in my opinion, goes up and down, yet the total energy stays constant. All right, so what we could hopefully deduce from that, I'm just going to pause it, is that as the PE goes down, the KE goes up. So that would be an inverse relationship right there, where they respond in opposite ways. We could also say that as the KE, the kinetic energy, as it goes faster, as it goes slower, then it must be going higher up in its swing, so potential energy goes up. But it's important to know total energy stays constant. If you look at those numbers, the total energy right now is 2.3 joules. Those two numbers above potential and kinetic will add up to 2.3. All right, so it says to show numerical values. For whatever reason, mine defaulted to it. And we need to reset to do this. Okay, so click reset. The pendulum should be at the top of its swing. When it's at the top of its swing, the potential energy is 2.3 joules. It has no velocity, therefore no kinetic energy at the top of its swing. And the total energy will just be those added together, 2.3 plus 0. You click play, and then try to click pause when it's in the middle of its swing. Got it. Alright, so when it's right in the middle, it's like the little purple string will be straight down on that y-axis. Gravitational potential energy at the bottom is 0 joules. Now it's all moving energy. Okay, so it's all the fast energy. So 2.3. 2.3 plus 0 for our total energy is 2.3 joules. So at any given time, what can you say about total energy? Well, if we take the potential energy and we add it to the kinetic energy, it equals the total energy, and that number never changes. Okay, that's really important, because this idea of conservation in physics, we just left the momentum unit. Conservation means does not change. So conservation of energy stays the same. Total stays the same. 2 pages are done. Number 5. Click and reset again. So just a little curly Q. You're going to click the graph tab. And it says that it defaults where potential energy is checked. You also need to turn on potential and kinetic and total. Hold on here. Nope. Do not have the total energy clicked. Just the 2 green ones. All right. So what's the relationship between potential and kinetic? When you click play, you get some crazy looking stuff. It looks like this. All right. This one is the potential energy one. This is the kinetic, because notice the first one was teal, the darker one. Okay, so you have those checked. As one goes up, the other goes down. We know that that means they have an inverse relationship. Now, I'm going to let you figure this next part out. Oh, sorry, inverse. I have to slide that down. You're trying to match up points A, B, and C. So if you look at A, you're trying to figure out where was potential energy the lowest. Was it in this graph, or this graph? And you just put an A there. Where was kinetic energy the least? And for C, where was it half and half? So where was it partially kinetic and partially potential? So an A, B, or a C goes here, A, B, C goes there, A, B, or C goes there. Number 7, suppose a pendulum starts with 100 joules of potential. Assume it has a height of 0 at the bottom of its swing, so it swoops by the ground. What's the maximum potential energy? We should be able to come up with that now, because we know that potential simply converts into kinetic. All right, so I'm going to leave you with that one as well. Activity B, now that you know how to run this, just going to draw your attention to make sure you have the mass at 1 kilogram, length at 1 meter. Gravity has changed. That will wreck your world if you do all these with different gravities. I want you to set theta to 0, so the pendulum will be at the bottom. Bar chart, numerical values, read the potential. What you'll do in this table, do what it says. That's the first part, all right? 0.5 kilograms for the mass, 1 meter for the length. Gravity is 6. For the height, here's how you figure it out. It is the 2 meters, because it says that the height is equal to 2 meters minus the length. Okay, so 2 meters subtract 1 meter means the height above the ground of the pendulum is 1 meter. 2 meters subtract 1.2, so that's 0.8 meters. 2 minus 1.1, 2 subtract 1.5. Potential energy, we should be able to know where to find that, right? Click the table or bar chart's probably easiest, whatever, doesn't matter. What is the relationship between potential energy of the pendulum and the values for mass, height, and gravitational? What I'm looking for, is it direct, is it inverse? Number 4, here's the formula. Mass times gravity times height. Okay, you're not going to make a rule. It's been a rule before any of us were ever dreamt of. Okay, that is the rule. Mass multiplied by gravity multiplied by height. So then they're just going to have you do some practice ones. You do not need to check your answer. Use a calculator. All right, just mass times gravity times height. We flip. Activity C. We have a new set of criterion. 1 kilogram. The length, L, set it to 1.3. Gravity is 1. Theta, negative 40. So in other words, the pendulum is off to the left. Select bar chart tab, show values. We've been doing this. Formula for kinetic energy. Okay, number 3, I want you to give this a shot. First thing you do is, oh, I see, we're solving for velocity on this one. Let's wait. Okay, 3, we're going to wait on this. That might be slipping into algebra 2 a little bit. But number 4, what's the maximum velocity? We'll wait on that too. Don't cross them off. We'll just go back and grab them. All right, so just wait on number 3. All right, get her done.